So I'm going to start this video by looking inside the piano. Excuse all of the music going on, it's a crazy household today. Here's one of the strings that have been tuned to exactly the same note so that this hammer can hit here, make that note on the piano. So in terms of frequency, vibrations within strings are measured in hertz. Now the letter A, which is here on the piano, plays this string. And that is tuned to 220 hertz. That's how you tune a piano. If you want to go up an octave, there's A there. If you look at these three black notes, it's the note in between the two last black notes. You can do that anywhere on the piano. If you look at these three black notes and do the note in between, that's also A. Now this one here is just twice the frequency of that. And Pythagoras, back thousands of years ago at the dawn of mathematics, figured out that if you get a random string and you halve the string, like on a guitar, if you got the whole entire string and you plucked it, and then you halved that string and plucked it again, the part that you've halved is exactly twice the frequency. So you're playing A down here with a big open guitar string, you halve it, you would play exactly one octave higher. So that's how an octave got defined, because before then we didn't really have music in the way that we have today. So Pythagoras invented the octave. Basically you halve the string length, which doubles the amount of hertz. And if you halve it again, makes it higher. If you halve it again, there's another A. If you halve it again, there's another A. So how did we get all the rest of these notes in between though? And if this is A, what are the other notes called? So this is A on a piano, this is B, C, D, E, F, and G. Then we go back to A again. So on a piano we have 7 notes. 1, 2, 3, 4, 5, 6, 7. And then we have a bunch of black notes. 7 white notes, 5 black notes in an octave, which adds up to 12. The shortest distance you can possibly get between 2 notes is called a semitone. And 2 of those semitones together make up a tone. So the distance between 2 of those jumps, that sound is a tone. In music, tones are really nice. We like hearing tones. Semitones are a bit weird. You don't normally find that in music. You normally find this. It just sounds nicer. So we normally use tones, but an octave is made up of 12 semitones. Now Pythagoras then went, well, if you divide it into half, you get an octave. What happens if I divide it into thirds? And he figured out if you have a note and you just block off a third of the string and pluck the 2/3 left over, you get what's called a perfect fifth. This has been considered a sacred interval. Since the dawn of music, and most Gregorian chants are written with that sort of open. This is called an open fifth. If this is a chord, this is the first note, second, third, fourth, fifth. So that's a fifth. This would be a third, a second, fourth, and a fifth. Now, Pachelbel's canon, if you know Pachelbel's canon, Pachelbel's canon is normally played at wedding marches. It does what's called a cycle of fifths. So a cycle of fifths is when you start with C, and it's called a cycle because it comes all the way back round to itself. If you start with C and you go up a fifth, you go to G. Now if you imagine that's where you were starting, G, and you go up a fifth, you go to D. If you imagine that's where you're starting and you go up a fifth, you go to A. If you go from A, you can go up to E. There's a fifth above that, and a fifth, and a fifth, and a fifth, and a fifth, and a fifth. And Pythagoras did that and went around a giant circle and discovered there are only 12 notes, essentially. Because this is a C here, this is also a C here. It doesn't matter how high the pitch is. To come back down an octave, you just halve that pitch. To go up an octave, you double the pitch. So, Pythagoras discovered that you can go from C, up a fifth, up a fifth, up a fifth, a fifth, a fifth, and then another fifth, a fifth, 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 and then the last note is a C. That's back to C again. And then you keep going with the cycle. So there are only 12 notes in our modern, I guess you can call it modern, 6,000 years since the beginning of all human civilization that we know of. There's only 12 notes. There's 6 tones or 12 semitones on a piano. So I like the sacred number of 12 because it appears in everything. If you recalculate music from scratch and no one had discovered music, you would rediscover these same 12 notes, which I think is amazing.